current density. You are following? Yes? Right. Now we have to get the integral form as this is called as the integral form of Maxwell's equation derived from Ampere's circular law. Take it out. This is the integral form of Maxwell's equation. This is the integral form of Maxwell's equation derived from Ampere's circular law. Ampere's circular law. That is again a differential form derived from Ampere's circular law. Okay. That is again a differential form that is given by integral of h dot dl is equal to integral of del cross h dot ds. Del cross h dot ds. Okay. That is equal to integral of j dot ds. Because h dot dl is equal to j dot ds. Then not, right? So using these two relations, what can you tell? Using these two relations, what you can tell? Integral of h dot dl is equal to del cross h dot ds. Okay, already we know that integral of h dot dl is equal to integral of j dot ds. So I am saying that del cross h to ds is equal to integral of j dot ds. Comparing these two equations, what can you tell about del cross h? Equal to j. Right? So this is called as the differential form of del cross h is equal to j. It's called as, take it down with me. Again. Okay. This is called as the point form. P-O-I-N-T. Point form. Point form or differential form of differential form of Maxwell's equation. Maxwell's equation. Okay, right. Next one. Right? Next heading. Maxwell's equation derived from Maxwell's. This is integral form of Maxwell's equation derived from Ampere's circular law. This is differential form of Maxwell's equation derived from Ampere's circular law. Now we are going to derive Maxwell's equation using Gauss law. Right? The third one. Maxwell's equation derived from Gauss law. Derived from Gauss law. Right. So here, what is flux? What is flux? How can you represent flux? Psi or phi, whatever it is. I can write it. It is equal to d dot ds. D dot ds. What is d, ma? I want the name for D.
Charge density. Charge density.
Not charge density. What is that? D is anybody? Electric. Very good. Electric flux density. So as we have seen here, electric flux density. In the sense, current density means I is equal to integral of j dot ds. Right? Current density is j. So if I want, I integrated j dot ds. So here I want flux. Flux is equal to integral of electric flux density into ds. So here when we want to form the differential form. So differential form is written here integral of d dot ds is equal to integral of del dot d into ds. Del dot d into ds, that is equal to volume integral of rho v into dv. Rho v into dv. Del dot d into dv is equal to rho v into dv. So from these two relations, what we can write? Del dot d is equal to rho v. This is called as the point form or differential form of Maxwell's equation derived from Gauss law. What is the integral form? The last one. Shannon, what is the integral form of Maxwell's equation from Gauss law? What is the integral form of Maxwell's equation from Gauss law? Thus, integral of d dot ds is equal to integral of rho v. Okay, and point form or differential form is equal to del dot d is equal to rho v. Okay, as last one, Maxwell's equation derived from Gauss law for magnetostatic field. For Gauss law for magnetostatic field. Derived from Gauss law for magnetostatic field. Okay, that given by integral of d dot ds is equal to 0. So this is the integral form. This is called as the integral form. Now the differential form is given by integral of d dot ds is equal to volume integral of del dot d into dv, that is equal to 0. So we have here del dot v is equal to 0. dv cannot be equal to 0, so del dot v is equal to 0. Here, this is called as the point form or differential form of del dot v. Del dot v into dv is equal to 0 or del dot v is equal to 0. dv cannot be equal to 0, ma. So what is the only possibility? Del dot v can be equal to 0. This is the point form or differential form of Maxwell's equation from Gauss law in magnetostatic field. Here magnetostatic field. What is that? Why I am telling magnetostatic field? What is B? Magnetic flux density. So there is integral or point form in magnetostatic field. Is it clear? So if they are asking Maxwell's equation, you have to write all these relations. What are the things we have seen? The first class, Maxwell's equation using Faraday's law. Very good. Faraday's law. Second one, Ampere's circular law. Third one, Gauss law. The fourth one, Gauss law from magnetostatic law. All the four derivations you have to complete. So clear, students? Right. Now we'll go for Maxwell's equation for time varying field. Maxwell's equation for time varying field. So time varying field is we are going to include that the equations are varying with respect to time. Only that change. Okay? Maxwell's equation for time varying field. Which means that integral of first one let me say that from Faraday's law. We have integral of E dot ds is equal to integral of minus integral of rho v by rho t into ds. So said rho t equal to time varying. Okay, so rho v by rho t into ds. This is the integral form from Faraday's law. Right? And using Stokes' theorem, I already told you, right? Stokes' theorem is not there for the syllabus, but you have to know this concept. Okay? dou v by dou t. This is the differential form. This is integral form and this is differential form. Yeah. For time varying field, listen, they are asking Maxwell's equation for 13 marks. You have to write all the four already expressions. Now this time varying also you have to write. Okay, and below each expression you can write. It is the integral of, right, flux density over differential circle. The definition below you can write. Okay, the next one. Maxwell's equation from Ampere's equatorial law. Maxwell's equation from Ampere's equatorial law. That is given by surface integral of del cross h dot ds is equal to surface integral of j plus dou d by dou t into ds. J plus dou d by dou t into ds. What is dou d by dou t? What is this dou d by dou t?
Different flux, electric flux,
Wait. Conduction current density and hysteresis flux. Is it not? Not back, hysteresis flux. You are not there. Okay, right? So these you have to write now. Then take it out. So we have, what can you tell del cross h from here? What is del cross h from here, ma? J plus, ma, del cross h. J plus dou d by dou t. Take it out. Del cross h is equal to dou d by dou t. Next. Maxwell's equation from Gauss law. Maxwell's equation from Gauss law. Again the same relation, integral of d dot ds is equal to Maxwell's equation from Gauss law. The integral of d dot ds is equal to integral of rho v dv. The same expression, the last I have written, no? The same expression will be given here. Integral of d dot ds is equal to integral of v rho v dv. Right? And finally we have got del dot d is equal to rho v, no? Here also the time varying the same relation. Del dot d is equal to rho v. Okay? Here del dot d is equal to rho v. That is the point form or differential form. Maxwell's equation from Gauss law we have derived, no, the same expression will be coming here. Del dot d is equal to rho v for time varying field also. The next one. Magnetostatics. What is magnetostatics law? We have derived already. Integral of del dot b dv is equal to 0 or del dot b is equal to 0. The same expression will be coming here also. Here that's it about time varying field, right? And here one more expression is given. Listen, one more expression is given for Maxwell's equation for harmonically varying time. In that case, only thing is you have to substitute omega t. Go through the book, the same expressions will be repeated. Only thing is you would have substituted a d into e power minus j omega t. The same expression. Go through the book, you can read through it. Okay. Now we go for the problem. Take it out. Magnetostatic adena. Del dot b is equal to 0. Okay. Right. Now we'll go for a problem. Take it out. If d is equal to, if capital D is equal to, capital D is equal to 10 ax vector, capital D is equal to 10x ax vector, 10x ax vector minus 4y ay vector, minus 4y ay vector plus k z a z vector, plus k z a z vector. I am repeating, capital D is equal to 10x ax vector minus 4y ay vector plus k z a z vector, microcoulomb per meter squared, microcoulomb per meter squared, and B is equal to, capital B is equal to 2ay 2AY millitesla, small m, capital T. Small m, capital T. Tesla, T is Tesla. What is the unit of flux density? Weber per meter squared, right? The Tesla, right? The same thing. Okay, find the value of K. Find the value of K. Find the value of K to verify the Maxwell's equation. To verify the Maxwell's equation for the region. Sigma is equal to 0. Sigma is equal to 0 and rho v is equal to 0. Rho suffix v is equal to 0. Right. Sigma is conductivity, right? So that is nothing but conductivity. So sigma is 0 and rho v is also given to be 0, which means that it is in free space. What is that? D and V are in free space. Take it out. Sigma is equal to 0 and rho v is equal to 0 implies that sigma is equal to 0 and rho v is equal to 0 implies that both D and B, capital D and capital B are in free space. ARE are in free space. Okay. So what is the relation you can go? What is the relation I can go? I want to know the value of K. What is the relation I can go? Maxwell's equation, you have got so many equations, no? Which relation can I go for obtaining that? Del dot D is equal to rho v. Take it out. Very good. Del dot D is equal to rho v. Loshni, book is there? Very good. Del dot D is equal to rho v. Del dot D is equal to rho v and del dot D is equal to rho v is equal to 0. Is it not? Right. Clear? What is that? Del dot D is equal to 0 or we have del dot D is equal to rho v and is equal to 0. Okay. So what can you write for del dot D? Del now what is that? It is rho by rho x of dx plus rho by rho y of dy plus rho by rho z of dz. Okay, this is what we have to find it out. What is rho by rho x of dx? What is dx then? Ax for dx component, what is it? 10x up to 10x, right? Plus rho by rho y of dy minus 4y, right? Then rho by rho z of dz minus here plus k. That is equal to 0, right? Now listen. What is rho by rho x of 10x? Prabhas, stand up. Rho by rho x of 10x. Rho by rho x of 10x. Okay, very good. Then rho by rho y is 4 minus 4y minus 4, right? Then plus rho by rho is plus k is equal to 0. So you can find out the value for k. Find it down. K is equal to 6 or minus 6 or? Minus 6 microcoulomb per meter square. So now K is equal to minus 6 microcoulomb per meter square. You please stop so that it is easy for me to complete the problem. I get the answers, no, by making you stand. K is equal to minus 6 microcoulomb per meter square. Have you all taken? K is equal to minus 6 microcoulomb per meter square. Shall we go to the next problem? Clear? Right? Next problem. A certain material has sigma is equal to 0. A certain material has sigma is equal to 0 and mu r is equal to 1. What is mu r? Relative permeability in relative permeability. Permeability in free space is mu naught, right? So mu r is equal to 1, right? If V is equal to your name, ma'am, your name, okay. If V is equal to 800 sine of, take it inside the bracket, 800 sine of, inside the bracket, 10 to the power of 6 into t, 10 to the power of 6 into t minus 0.01 minus 0.01 is at ay vector volt per meter. Yes. Using Maxwell's equation, find epsilon r and h of z comma t. Okay. Find h of 0 comma t. 0 is the number. Sorry, z comma t. Right, somebody can read the problem. Somebody can read the problem.
Certain material has sigma equal to 0, mu r equals 1. If B equals 800 sine bracket 10 power 6 t minus 0.01 is at ay vector B per meter. Using Maxwell's equation, find epsilon of r and h of t.
H of z command. And you are asked to find out the epsilon. Right? What is given? E is given as 800 sine 10 power 6 into t minus 0.01 is a ay vector. Right? If you have not written like this, please take a construction. This is your statement for E. Okay? Using Maxwell's equation, you have to find out the value of epsilon r. How do you find it out?
Del cross
Very good.
equal to 0.
Del cross h is equal to
J.
J, okay. J can be written as any other relations? So, very good. Dou d by dou d. D can be written as, like this only you have to keep on, then we can proceed. D can be written as epsilon into E. What is epsilon? Epsilon naught into epsilon r. Epsilon naught is in free space. So you can find out epsilon r. That's it. Okay. So we have to start from del cross h and then you have to simplify. Clear? Like this you have to think. You have to remember all the relations. Which relation holds good for our answer? You have to think. You only told the answer now. This is not. Del cross h is equal to j is equal to dou d by dou d is equal to epsilon e, epsilon is equal to epsilon naught into epsilon naught. So from that you can find out epsilon. Is it clear? Right? And then we have asked to find out h also. Is it done now? How do you find out h? Think, you can answer. How do you find out h? Epsilon naught, you only told me the answer. Tell me like that for h. One clue. Del cross e has to be found out. Del cross h has to be found out. Del cross e has to be found out. Anybody? Del cross e is equal to minus dou Right, find out. Let us find out. First, let us find out H and then I'll go for epsilon armor. Right, take down. Del cross E. First, let me find out del cross E. Del cross E. So, how do you find out del cross E is? Listen here. You are given with E vector. You have to have the values Ax, Ay, Az. Yeah, Ax, Ay, and Az. But we have again here system written as dou by dou x, dou by dou y, dou by dou z. Okay, and E is having a parameter of only Ay. So what about other terms? It becomes 0. So if they have 0, right? Cy, right? 0. Right? The next step, I can replace the Cy by the term. We'll have Ey and then we simplify. Why we have to include that and we have here Ey. I'll simplify it and we will be getting it. Okay. Now, listen. Ax into, please listen here now. We're going to find out the value. Ax into, next one, please listen the class. I'm taking something important. Please listen the class. Ax into, 0. We will have this, right? So I write it as Ax into, dou by dou z or minus, see, that is what I was telling that minus dou Ey by dou x, dou z. Okay, next, what other terms will be coming? 0. This will be 0. Here, this term will be coming, right? So we have here plus Az into dou Ey by dou x. That's just like we have to differentiate and we have to simplify. Okay, so let us find out what will be the answer. Simplify it. We have to differentiate with respect to this term will automatically become 0 now. This term y, no z term. So this term alone will be having. So when you differentiate, what will be your answers? Anybody? 8 by differentiate. So 8 into. Tell me the answer.
0.01 x
divided by 100. 100 gets cancelled out. So 8 alone will be coming out. Simple calculation. Listen students. My into 0.01. 0.01 is it? So 0.01 is divided by 100. Yes students, listen. This step, how did I get 8? How did I get 8? When I differentiate, you have to, sign will become cos. Z term alone you have to multiply. So multiplication of 0.01. 0.01 can be written as 1 by 100. So that 100 and 800 will be getting cancelled.